Okay, everybody, this is my cap dump. I'm working on a big cap dump. Well, it's big to me. And this is the last panel for it. And like I told you before, or I showed you before too, in pictures, not a video, but it's made out of this bathroom shower stall fiberglass. It's really cheap stuff. And but it's strong, you know. It's not like buying a circuit board that size for mounting things. Okay, and I wanted to show you down below here the other one. I got this large disconnect box and I'm putting it all in. And the thing I wanted to show was the bus bars. You see the plus and the minus there, they're like drawers. They slide in and out like this. And I got some mismatched caps there, but they're real good. Most of them are 13s or 15s or 1000s. The smallest is a 1000. And you'll see the bus bar there. I wanted to show you the bus bar if I can. I've got a piece of brass. Here's my brass. Now here's a piece of brass that I cut, and then I fold it over and make bars, and then solder my brass and copper leads. I don't know if I can show you that very well. I'm showing you the caps, and then if you look down at this way, I got the tape over the bus bars as a protective measure, but in between you'll see the little bumps. That's where they're soldered together. So you want to be safe with this stuff. You know, you want to create an arrangement so that you don't get a shock, and because there's a lot of power there. And you'll see the individual 14 gauge wires under there, and then they connect to the bus bars, one positive and one negative. So it's pretty compact that way with the bus bar, and so I can just slide those in there. Another thing I wanted to show is this little setup here I'm using all the time. I'll charge one of these little batteries for a lantern. What did I do with my... I gotta have an alligator clip here, doggone it, to show you. But anyways, also while I'm getting that clip, I wanted to show you my my other heat sink that I just got. It's a fan housing with a heat sink. I don't know if you can see that very good. I figured out how to work this camera a little better. This came out of an old-fashioned UPS, you know, uninterrupted power source, and it has these older, I guess they're regulator parts, but it's a perfect heat sink for a smaller maybe charge controller. If I might copy the idea somehow. I don't know that much about the charge controllers, but I do have a heatsink and a fan right there. And of course you guys remember this other one. I don't use that one very much, that SG there, other than to charge my 30-volt batteries and ones that are really little. But it works good on bigger ones too. I should find that. But anyways, back to this. What I could do is put the, here we go. I can put this right on there instead of using a gator clamp. It'll work alright. And I like to put an amp meter on there so you can see it. So you can see the amp meter going up and down and up and down. So that's what we're going to do for a second here. And I wanted to show you the operation of this little machine. And it's really great. Like I told John, I use this thing every day. Now in the beginning, I thought I was getting 400% or whatever, like a lot of us. And when we first start out and we're beginners at this, and I'm not. I'm just getting a normal, hopefully a one-to-one charge. But the main thing is that I'm able to revive batteries. Excuse me. Now you see, just ate dinner. You see this right here? This is a nice battery, and I've got an amp meter on that, and it's been converted to ohm. You'll see that white tape. Wherever you see tape on a battery of mine, you'll notice that it is a converted battery. So now I guess I goofed here. I'm gonna have to redo this with one hand like everybody says, right? But I want to come up here and show you this because I've been meaning to show everybody this little machine, but it's actually my middle-sized machine. And then we'll put this gator clamp on here, and I have two on there. You'll see I got one black one and one green one. The green one goes to the cap dump, and then when I hook these two up, or if I just hook this up, you'll see the cap dump start flashing. See over there the flashing? I got this old box, I just stuck it in the cap dump. It's a little 15,000. Just a small grouping of caps, probably fit inside of a hardball. And then I got this one I can add on. This makes it bigger because this is 48, but I usually unhook that. And there's two leads here, so you can increase the size of your cap bank, and you can also measure your voltage right here. That's one thing that that's important about this video, really, is that you see the setup. You know, you see how people are doing this, so that you have something to go on. Now if I got it flashing, but I don't have the power on, so now I'm going to put the power on. And before I do that, and I'm going to tell you more about the setup, let's get the meter running down here. Can you see that meter? Okay, guess I unhooked the meter and we got a lot of glare, so I'll have to work at it, but the glare is not as bad as it was. Okay, there we go. And set it at, this is really not the meter for it, but it's already showing 13 volts, so this thing is charged. I ran it and ran it and ran it to on real low. Now this thing don't draw much power. If you'll notice here, I got a little switch down here. You see this little switch? This way and that way. Makes more, and this little knob over here, more and less, you know. I got like a high and low setting, and then you'll see over here on the amp gauge when it turns on. Now watch, I'll turn it on and we'll see how many amps it's drawing. Whoops, slid off there. Okay. Now you see the meter. The meter is moving, and so am I. I'm trying to have a steady hand here. Sorry about that, but I don't even think you can see that meter well. But let me move it around here to the light better. There, can you see that meter? That's a 1 to 0 amp meter. 0 to 1 amp. Let's see if I can get that to focus right. Well, anyway, it's about 400 milli. You'll see it fluctuate up and down, and the light is flashing in there. And I got a lot of wires on this one because I can charge 4 batteries. I got 4 hots and 4, you know, black wires. If I want to divide up the 4 channels to 4 batteries, I can do that too. But right now I just got it all 4 of each going to the cap dump there. See all those clips? And then that comes out to the battery. Now the amp meter over here is jumping. If you can see that. That's a small amp meter, and it's throwing about 1.5 amps or so. And I don't know about the glare and getting these things to so you can read them, or what's wrong with this thing. Maybe that's better. I don't think you can see it, but it might be blurry, but you can still see that it's about 1.5 right there. Okay. Now looking at the meter, you'll see this is jumping all over the place. Like I said, this is a fully charged, and really I shouldn't have it on that setting right there. I should switch the switch down here to a lower setting so the amp draw goes down. I'll flip it again, it goes up. Now I can also take it down there and I can adjust it up and down. See, I can adjust it up to there with that knob and back down for smaller batteries. Now look at the amp pulse. See if I can get the glare out of this thing. I guess I'm right in the light. There. You'll see the amp pulse is lower. It's like maybe 3/4 or almost a 1 amp pulse, which that's good. It really does the trick. Now let me put my clip lead back on here. Kind of in the way there too. But, okay, over on this side of the cap dump where it's flashing, see it there? I can go around here, and I got 2 little knobs. Now one's got a pencil stuck in there. I turn that pencil eraser or that other knob, and I can adjust my time. Now watch when I adjust the pencil one, you'll see the flash change on you. I'll speed it up. See, it's going faster. And what you want to do is you want to set this cap dump, take your lead off your battery. Here's your meter. It's running about 15.6 or 8, jumping around there. Take off your negative lead on your battery, which is being pulsed, and hook it to the cap dump on the negative side, because the positive is always hooked on these. Well, on this particular one, because it's a negative discharge. So I having a little bit of trouble getting it untangled here. I'll get that hooked up, and right there. Now one side is negative and one side is positive. I just scribbled it on there. See the little solder joint there? It's little or nothing, just holding on. And now I'm reading the volts on the cap bank, not the battery. Now it's going between 20 volts, around 21 volts, and 18. Now if I reach up here on the cap bank and I adjust that little pencil eraser around, I'll slow it down a little. See it jumping there? See how much I slowed it down there? Way down, right? Now let's look at the meter. Now the meter is showing down to 19, but it's up to 25 or 6. Right? 26 plus, down to 18. See it going up and down? It's going up and down with each dump on the light. Now I can raise that up some more and make it go slower. And when I do, my amp pulses, if you'll notice the amp pulses, they're bigger. Of course, there's more power being saved back. And then on our meter, we're seeing 29 volts, 30 volts, down to 18. Right around 30 volts to 18 is where I like it. And So now I set my cap dump to the voltage because I have a 12 volt battery. I set my dump where I want it. Now I can take this back off of here and put it over here on the battery. Alright. Now what's the battery reading? The battery's jumping around between 15.7 and 16, about 16 something. So it's fully charged, like I said. And I just wanted you to see the amp draw on the meter. It was only 200 milli. And this is a 5 amp hour converted alum battery. And believe me, I get the full 5 amp hours out of it. And there's the meter. 1 amp, I'm getting like about a 1 amp pulse out of it. Now if I switch down here, I can get a more power. I switched it down. See, I'm getting like a almost a 2 amp pulse there. Or I can turn it up some more. See my meter over here? My amp meter? I can go up to half amp all the way up to a full amp right now. Look at my pulses now. I'm over there at 3 amps or more. And look at the meter now. It's strong. It's way up there. It's overcharged, you know. And I've been overcharging this one because I've been using way less power. I've been switching down like that and then turning it down and then just leaving it all day. But this is a really cool little tool. If you guys are going to make a little battery charger, this is really the way to go. Well, it's one way to do it. And now see, I'm going to increase the cap dump. The cap dump is 15,000 inside this little junk box I put together back about a year ago. I want it bigger, right? I want it to about 60,000. Okay, which the stamps inside, you know, the transistors, they can't handle it really for long. I hooked it up, and you'll notice, let's see, you'll notice the pulses are the same, but what will change is the voltage. The voltage on here, of course, is going to be high because it's already charged, but I'm talking about the dump voltage. Now let's go back over here to the dump. The dump voltage, which means I got to hook the meter up there to the dump voltage. The dump voltage is lower now. It's down there at like 25 and down to about 19 volts, right? See that? It's 26 maybe and 19. See that? Now watch what happens when I remove the clip lead on the additional cap. Alright, I'm going to reach over here and remove it. Now watch the voltage go to 30. See, it was 30 volts now. 30 volts down to 19. See how that changes it? You got to change your timing for the size of your capacitors is all. And you can get more or less kick out of it depending on what you're charging. Okay, well that's what I wanted to show you. This is Brother Mikey on the farm, and it's Science Energy Farm. And I just mainly wanted to get in here and show you my bus bar rails, because I'm getting excited about this. I got these big brick parts, and I'm making this big cap dump for 36 volts. And then I've got that other heat sink too for the, like I said, it's a big heat sink to put a lot of parts on all the way around each side here for like a regulator, a series pass regulator type of thing for solar or for wind or whatever. This is something to zap a battery. But the thing about that is I was wondering if maybe I couldn't use coils with that. Maybe I could use, you know, the bigger Bedini size twisted up coils with that, and in like a generator mode, and still pass a lot of current in gen mode and kind of get like a balance or a trade-off between between just a straight charge controller and a Gen mode Bedini style type of energy pump, where you can still use the G field, is what I want to think about. I want to use the G field. I want to be able to pass more than 5 amps. You know, I want to maybe get up to 50 amps. Because I've already built me some solar panels out of the good wafers for that. Okay? And while we're in here, you might as well see this mess of batteries I'm working on. Look at that, huh? Not bad for boneyard batteries. And you saw that before. I took some pictures, and I keep getting more. And I got one big mess in here of batteries everywhere. See it there? And there's my machine that's going right now. I'm zapping. I'm using 24 volts right here, those two batteries. And I'm using this little box right here. It used to be 24 volts for like a garage door opener or something. And I put a dimmer switch in it so that I can raise it up and down. I can charge 5 volts with it, or 20. You know, I can charge higher and lower amp draws with it. It'll produce up to 40 volts. You know, open circuit connection. That's kind of stuff I like to tinker with. Nothing expensive here. Just all my time involved with it. And there's that machine. It is a splatter mess of wires. You cannot see it very well. I want to take that dump that's on the top there, if you recall, and I still want to use it, and I want to switch these terminals right here. There's a red and a black terminal right there. That's coming off the big coil that's down here in the box underneath. I want to get this ship shape a little better, you know, shore it up where I don't have all these alligator clamps. And I don't know if you can hear that whining, but you can see it dumping. I've got it up way sky high right now. I'm dumping it like 42 volts down to 18 because I'm working on a battery that was heavily sulfated. It's a nice battery. I'm working on jackhammering all that sulfation off there. So that's what I'm doing there. Just wanted to pop in and say hi to everybody on the Science Energy Forum and around the world on YouTube. If you want to charge batteries, you energize them. You get ringing going around. See, these two batteries are being charged by that 24 volt thing, but there's ringing going on inside these batteries from this machine. So these batteries stay better, and they stay charged, and they don't sulfate with all that ringing. You say, well, what ringing is there? Well, there's ringing in this whole circuit. Because I'm running, well, you'll see the switch down there, the red switch, the 30 amp light switch. I can switch it up, and that's Gen mode. You know, and the amp draw here will go way up. Now I can turn that amp draw up too on this. You can see it go up there. You can turn it up and down. And with Gen mode you can send it up to, you know, higher, different voltages that it depends on what voltage really that you're charging and what voltage that you're charging with. Now right now I'm charging with those two batteries, which is 24 volts. I'm feeding 24 volts into this circuit and this dump right here, and then it's going into these batteries down here. Well, right now I'm just doing this one. You'll see I alligator clamp it on there, and then I put some PVC tape on there so it don't jump off on me. I don't want to lose my machine, you know, because if it's unattended and it hops off, I'll be in a world of hurt with that machine. But let's see if we can't turn the meter on here. There it goes. I got it at 13.9, which is good. I had it running like on 1.25 amps all day, right up here. I had it running along at about 1.25 amps. I just turned it up and down. I haven't had it much power on it. And I just started this, and on that little battery, they're all like this that I'm showing you. These type of batteries. They're big batteries. They're 35 amp hour batteries. They'll give you more than a car battery will. And the right type of energy. And long, continuous. And this one is not converted yet, but all these 4 right here that I have are not yet converted, but they're going to be tonight. Here's some that I did convert over there. Well, you can't see, it's dark over there. But that one up there that I was showing you earlier with the little machine, see it pulsing away? I got it on the old-fashioned radiator. See it there? Just that little board, and that's the whole setup. I charge all my pen light batteries. I charge everything with that right there, the little ones. And here's what I did with my pen light battery station. I just took one of these, gutted it, right? And then I took the wires out the end, and I just clipped the leaded on there. I put my, it's not set up very, conveniently. You need a technician to run it. I can't let the kids use it. So I really need to get a 100 volt shut off, or actually a 50 volts. If it reaches 50 volts, I need to be able to shut it down, something like that. Then I could let them charge with it. But that battery that's in the back there, those are nice batteries. And I converted that one. And that thing will go down on a long linear decline. It's really, really good with Elm. All these batteries are. Now I've thrown some out now, don't get me wrong. I got a pile that's either broken or something like that, right? So I just wanted to pop in here and talk about these batteries, as well as that cap dump I'm working on. And I don't know where I put my sinks. I guess I put my heat sinks in here somewhere. I got some more caps. I might hang these caps on the side here. I don't know if I need more. These big ones, I got a pile of those I could use, right? And I don't know where I put those. But anyways, I showed you in a picture before what the brick looked like. They're sitting here. Oh, that's right. I hid them away. I didn't want them to get dented up. Here's one right here in the drawer. They're both in this drawer. This is the heat sink with the in-gate. No, it's a transistor module. Big 150 amp industrial motor control. And this is the same, only shorter heat sink with the 2 individual diodes on it. I don't know if those diodes are very fast though. But they come off of a pulsed arrangement for like motors. And it probably would be nice to have a faster one for this stuff, for Radiant. Okay, just want to pop in and say hi to everybody, show you my progress on my bus bars. I want to get that big cap dump so I can charge all these batteries. See that battery there? That's a 100 amp hour battery. There's a 100 amp hour battery down there. See it? Altogether, I got about 800 amp hours here that I got free, practically. Well, I had to pay some for them, but not full price. So there you go. I can't think anything more to say. That I've been itching to get on here and say some stuff about these batteries right here. Now you can overcharge these batteries, this 24 volts, these two 12 volt batteries, if you use a constant current. But if you use a normal charging battery charger that only takes it up to 14 volts or 13.8 volts, the ringing that goes on in there will bring it up even higher, and it will keep it desulfated. But I would rather use not that old block transformer. I would rather use a solar panel and a charge controller like I've been talking about there. And but I'd like to use it in a gen mode if I could. I don't know, I'm just thinking out loud. I'd like to use those coils, that coil down there, that 14 gauge wire, 4 channels. I'm thinking, how could I take that or another one like that and hook it up to this, right? To make it a half and half, make it a charge controller in gen mode, and pass more amps, a lot more amps, like 10-20 amps we'll say, but still benefit from the G field that's created in generator mode. Okay, now you know what's on my mind and what I've been thinking about. Talk to you later.